Hi all, welcome you all for the second lecture on computer organization and architecture. So today we'll be seeing about registers that are present inside the processors. In the last lecture we have seen about the architecture, the von Neumann architecture, what are the parts of the computers and what is the purpose of each and every part that is present inside the computer system. So today we'll be seeing in detail about what are the registers available, what are the special purpose registers available, what are the general purpose registers available inside the processor, and what is the purpose of each and every register that is available inside the processor. Okay, we'll see in detail about it. First, I have considered a memory which is a main memory. I've taken an example of main memory of size 4096 into 16. 4096 is nothing but the number of words that are present in the number of words. So what is a word? It is a unit for measuring memory, like byte. Byte, we all know that it is 8-bit is called a byte. So word, based on the architecture, the size of word varies. So this, I have taken this as word addressable architecture. So the total number of words in our main memory is 4096, which means consider main memory as array of memory locations available. So total number of words is given as 4096, which is from 0, 1, 2, 3 and goes on to 4094. So this is total number of words, total number of word locations that is present. What is the 16? 16 is size of each word available. Okay, so this is equal to size of word. So in our example I have taken like this, like main memory is 4096 into 16. 4096 is nothing but the number of words available, number of blocks are available inside the main memory, and size of each block is 16-bit. This is bit. Okay, size of each block is 16-bit, which means every block is of 16-bit size. Okay, so this is 16-bit size and this is 4096, 0 to 4095. Now, which means, so for 4096 can be written as 2 raised to the power of 12. Okay, so each and every memory location will have an address associated with it. So this is 2 raised to the power 12. So 12 bits are required to represent the address. So first address will be 0000, 0000. So 12 bits of 0. Next is again 001. So 0010. So this is how your addresses will be represented for this main memory. So this is your main memory, this is your primary memory or anything. So this is how your main memory is represented for this example. So your main memory is taken of size 4096 cross 16. 4096 is nothing but the number of words. 16 is size of each word that is present. Okay. So this is all about the main memory. Okay. Now let us go on and see in detail about what is registers. So registers, there are two registers available, which is special purpose registers and general purpose registers. We'll see one by one. Special purpose register. So among the special purpose register, the first register that we'll be seeing is memory address register. Memory address register. We all know in von Neumann architecture, we have seen in the last lecture that the instruction and data both are inside the main memory. So for example, say there is a data here, say some 1000, some data is present here, 100 is present here. Here there is an address, say instruction, add R1, R2. Okay, so now we saw that in execution of a program, all your instructions are first brought into the main memory, and instruction is one by one fetched by the processor and the processor will execute the instruction. Okay, so the instruction is also available inside the main memory, and the data is also available inside the main memory. So this is how your instruction will be: add R1, R2. So there will be an address for this. For example, 1000. So 12 bits long, 000, 1000 is the address for this instruction available. Okay. So now, if a processor wants to fetch the instruction from this address, from this 1000 address, so it will use this memory address register to store the address and to pick the instruction from the main memory. Okay, so basically this memory address register, it is used to store the address so that it can fetch the data and the instruction from the main memory. So what will be the size of this memory address register for our example is, it basically stores the address in the main memory. So address is 12 bits long. Okay, so that's the size of the memory address register for this example, which means starting from 0 to 11 bits, which is total number of bits is 12 bits long. So memory address is 12 bits long in this case. It is actually used to store the address so that it can go and pick the data and instruction from the main memory. So that's all about the memory address register. So the second special purpose register that we'll be seeing is memory data register. As the name suggests, memory data register is going to store the data that is present in the memory. Okay, when you are going to the main memory and bringing some data back to the registers, to the processor, this register is used to store the data that is brought from the main memory. So when you are bringing a data from the main memory, this memory data register is used to store the data from the main memory. So what will be the size of this memory data register is? It is actually the size of data. What is each word size? Each word is 16-bit size in this example. So memory data register is obviously going to store data. So data, what is the size of data available here? It is 16-bit, that is 0 to 15. Okay, so now what is the size of this memory data register? It is 16-bit long in our example. Okay, so memory address register is going to store the address of the main memory, wherein you can go and pick the data and the instruction. Memory data register is going to store the data that is brought in from the main memory. Okay, so the sizes are okay, fine. Now, the next special purpose register that we'll be seeing is accumulator. Accumulator, it is basically used to store the intermediate data in the program instruction execution. Instruction execution's intermediate data is being stored. It is being stored in the accumulator. So accumulator is it is solely used for data storage. As we all know, in our example, the data size is 16-bit long. So obviously the size of accumulator will be 0 to 15, which is 16 bits long. Okay, now, so the next special purpose register that we'll be seeing, that is an important special purpose register, which is program counter. Okay, as we all know that in the von Neumann architecture, the complete program that is in execution, that will be present inside the main memory, as well as the data is also present inside the main memory. Now, so this is a program. I'll write one more instructions here. Multiply R3, R4. Some instructions. The program is completely loaded inside the main memory. Now I am executing this instruction. Say add R1, R2. I have to pick from the address 1000. 1000 address picks the data, add R1 and R2, and the processor will process that instruction, and it will execute that instruction. And what will happen? It has to move on automatically to the next instruction to pick the next instruction and execute it and give it to the processor for execution. Okay, so this has to be done in a serial manner, which means first instruction has to be executed, then the next instruction has to be executed, then next in a sequential order it has to be executed. This program counter solely serves this purpose. program counter will store the address of the next instruction that has to be brought into the processor. Okay, currently this is the address wherein this is the instruction I am going to execute. The processor is going to execute, which means the next instruction will be 1001. The next instruction will be available in 1001. The next instruction will be available in 1002. Okay, this program counter will automatically increment to the next instruction, and then it will show the address of which instruction to be picked by the processor and it to be executed. Okay, so basically what is this program counter doing? It is storing an address of the next instruction of for execution, which is to be brought into the processor for execution. So this is storing address. So what will be the size of the program counter in this example is the size of the address. The size of the address is nothing but 12-bit. So 12-bit, so it will store 12-bit address. Okay, so program counter is basically used to store the address of the next instruction, which is to be, it is automatically incremented to get the next instruction from the main memory. Okay, now the last special purpose register is instruction register. Instruction register, as the name tells us, instruction from the main memory, it is brought in and stored in the instruction register, and it is temporarily being stored. Once the instruction from the main memory is brought into the processor, actually all these registers are inside the processor. So register, instruction register will bring in, the instruction will be brought into this instruction register, and temporarily it is stored in the instruction register, which will then be decoded by the control unit, and the control signals will be generated on what operation has to be done, and the control signals will be given to the arithmetic and logic unit, and the process continues. Okay, as we have seen it in the previous lecture. So the sole purpose of instruction register is it will temporarily store the instruction which is brought in from the main memory, and it helps in decoding the instruction, and then the further processing of the instruction will be taking place. So the instruction register brings the instruction and it is stored. So what is the instruction? Instruction is actually, it is the data. It is also, it is part of the memory. It is the actual data that is present in the memory. So what will be the size of this instruction is again the size of the word. Size of the word is 16-bit, so 0 to 15, it is 15-bit. Okay, so these are the special purpose registers available inside the processor. And coming on to the general purpose registers, depending upon the architecture, you can have as many general purpose registers as possible. And this general purpose register is used to store data. So obviously data 16-bit in our example, the size of data is 16-bit. So every general purpose register will be 16-bit, which is used to store data. It is used in manipulating the data and everything. So this is the type of registers that are available inside the processor, the special purpose registers, the general purpose registers. Hope you all understood this registers concept. Thank you for watching this video. We'll see in detail about bus architecture in the next lecture.